when we are talking about inverses, remember inverse sine lies in quadrants 1 and quadrant 4. And remember, inverse sine is only going to be angles between negative pi over 2 and pi over 2. Inverse cosine, remember, lies in quadrants 1 and quadrant 2. And remember, inverse cosine is only going to go from 0 to pi. Inverse tangent, just like inverse sine, is going to be in quadrants 1 and quadrant 4. And remember, inverse tangent is going to go from negative pi over 2 to pi over 2. How come I didn't put brackets around negative pi over 2 and pi over 2 for inverse tangent? It's not included. Remember, that's where tangent's undefined. And then inverse cotangent, remember, is in quadrants 1 and 2. And again, I'm putting parentheses around 0 and pi because that's not included for inverse cotangent. So we're going to be doing composition two different ways. Once with values from the unit circle, and just like we've done every other concept we've done this year, you're going to have to be able to use the reference triangles as well. So again, when you take a look, first of all, at the unit circle, we always look on the inside out. Now remember, this is where you're going to have unit circle problems along with inverses composed together. So take a look at the sine of pi over 3. So this is a unit circle function. Remember, sine is the y-coordinate. So what's the y-coordinate at pi over 3? Square root 3 over 2. So that takes care of the inner function. Now look on the outer function. So now I want to find the arc sine. So now this is where this is an inverse. Remember, inverse sine, I have to be in quadrants 1 and 4. So what's the angle that has a sine value of square root 3 over 2? I know I'm in quadrant 1 because it's positive. So what's the angle going to be? Pi over 3. This is where you really have to know that unit circle. All right? Any questions on how I handled number 1? So now let's take a look at number 2. So again, cover up what's on the outside and let's look on the inside. Cosine of 4 pi over 3. So again, this is unit circle. So again, 4 pi over 3 is in quadrant 3. What do we know about cosine in quadrant 3? It's going to be what? Negative. So what's the x-coordinate down there in quadrant 3? It's going to be negative what? 1/2. Okay? So remember, cosine of 4 pi over 3, this is the unit circle. So you're looking for the x-coordinate at the angle 4 pi over 3. Now we're going to look on the outer function. Now I'm going to look at the inverse cosine. So where are you allowed to be for inverse cosine? For inverse cosine, remember, we can only be in 1 and 2. So because it's negative, I've got to pick the angle in quadrant 2. So what angle has that x-coordinate of negative 1/2 in quadrant 2? 2 pi over 3. Okay? So any questions on number 2? So this is where you've really got to now keep track in your mind. Is it unit circle or is it inverse? Always get that location. So now let's take a look at number 3. Always work inside out. So now it's an inverse sine. So inverse sine, remember, I'm allowed to be in quadrants 1 and 4. So because it's negative, I'm in quadrant what? 4. So what's the angle that has that sine value of negative square root 2 over 2? Negative pi over 4. So now I'm going to look on the outside. So now I'm back to the unit circle, so I'm opening myself up to all 4 quadrants. What's the sine of negative pi over 4? So again, negative pi over 4 is in quadrant 4, so that's going to be what? Negative square root 2 over 2. So any questions on 3? Let's take a look at number 4. The arc cosine, again, we're dealing with inverses. So arc cosine of negative square root 3 over 2. So again, remember, inverse cosine, I'm in quadrants 1 and 2. So because it's negative, I've got to pick the angle in quadrant 2. So what's the angle in quadrant 2 that has a cosine value of negative square root 3 over 2? So I'm in quadrant 2, 5 pi over 6. And now I'm going to look on the outside. And now what's the cosine of 5 pi over 6? Cosine of 5 pi over 6 is going to be negative square root 3 over 2. Notice sometimes, ladies and gentlemen, when you do a composition with cosine and its inverse, they cancel each other out. Sometimes they don't. If you take a look at example 2, they did not cancel each other out. So don't assume just because it's a cosine with an inverse, they're always going to cancel each other out. That doesn't always happen. So now let's take a look at the arc sine of sine of 11 pi over 6. So again, sine of 11 pi over 6. This is back on the unit circle. So again, what's the y coordinate at 11 pi over 6? Negative 1/2. Be careful of the negative. So now let's look on the outside. So now I'm dealing with inverses. So inverse sine, remember, I'm only in quadrants 1 and 4, but because this is negative, I'm in quadrant 4. So what is the arc sine of negative 1/2 going to be? Remember, the angles have to be between negative pi over 2 and pi over 2 for inverse sine. Negative pi over 6. So any questions on number 5? Yes, Wally?
Why does that have to be negative pi over 6?
Remember, for inverse sine, the angles have to be between negative pi over 2 and pi over 2. Okay? You guys go ahead and try number 6 on your own. So did we all come up with 3 pi over 4? All right, questions on that? You guys go ahead and try number 7 and number 8 for me. So what did you guys get for 7? Negative pi over 6. And then what did you get for, oh, it should be negative 1/2, I'm sorry. I didn't finish it. So number 7, you should end up with negative 1/2, correct? And then for, because negative pi over 6, that's quadrant 4, and sine is negative in quadrant 4. Yep. No, because negative pi over 6 is in quadrant 4. So, and sine is negative down there in quadrant 4. Okay? Any questions on 7 or 8? So now let's take a look. So sometimes you do composition where the functions are mixed together. So again, you still have to go on the, cover up what's on the outside and look on the inside. Arc cosine of negative square root 2 over 2. Where are you allowed to be for inverse cosine? You're in quadrants what? 1 and 2. So because it's negative, you're in quadrant 2. So what's the angle in quadrant 2 that has the cosine value of negative square root 2 over 2? 3 pi over 4. So now I'm going to look on the outside. So now I want to find the sine of 3 pi over 4, which is a unit circle. So the sine of 3 pi over 4 is what? Square root 2 over 2. Because remember, sine is positive in quadrant 2. So now let's take a look at number 2. Again, cover up what's on the outside and look on the inside. Inverse sine. Where are you allowed to be for inverse sine? One end, 1 and 4. So because it's negative, I'm down here in quadrant 4. So what's the angle down there in quadrant 4 that has a sine value of negative square root 3 over 2? Negative pi over 3. So now I'm going to look on the outside and I want to find the cosine of negative pi over 3. Remember, negative pi over 3 is the angle down there in quadrant 4. So what's the cosine of negative pi over 3? 1/2. Okay. Questions on those two? Let's look at number 3. Cosine of pi. Cosine of pi, again, unit circle. What's the x-coordinate at pi? Negative 1. So now look on the outside. So now what's the inverse sine of negative 1? Mm-mm. 1/2 is at pi over 6 for sine. So cosine of pi is -1. So now inverse sine of -1 is going to be at what angle? -pi/2. Okay? You guys go ahead and try number 4 for me. What'd you guys come up with? Hopefully 5pi/6. It's negative. So any questions on number 4? All right, you guys go ahead and try the next 4 for me. Go ahead and try 5 through 8 for me. And then we'll work on some tangents. You can check your answers up here when you're done. Okay, like I said, if you need a copy of that unit circle in front of you, have it out in front of you. Any questions on 5 through 8 before we take a look at the tangents and the cotangents of composition? All right, let's take down now at number 1 down here involving tangents and cotangents. So again, always still cover up what's on the outside and look on the inside. So the tangent of 5pi/3. So from the unit circle, what is the tangent of 5pi/3? -√3. Watch your quadrants. Make sure you don't misplace those negatives. And now I want the arctan of -√3. Remember, inverse tangent. Always know the location. Your location, your location. Inverse tangent, you're in 1 and 4. So because this is negative, which quadrant are we going to be located? We're going to be located in quadrant 4. So then the angle in quadrant 4 that has that tangent value of -√3 is going to be what? -pi/3. Remember, inverse tangent, the angle has to be between -pi/2 and pi/2. Let's take a look at number 2. So again, cover up what's on the outside and let's look on the inside. Cotangent of 7pi/6. So 7pi/6 is over there in quadrant 3. And I know tangent and cotangent are positive. So what's the, it's not √3/3, but it's going to be √3. The tangent of 7pi/6 would be √3/3.
Whenever it's cotangent, it's flipped around, so it's like, if it was to be, if it's like an over 3, then it's a square root 3.
It's the opposite of the tangent, yeah. And now the inverse cotangent of √3. So again, inverse cotangent, you're in 1 and 2. So since this is positive, you're going to be in quadrant 1. So what's the angle in quadrant 1 that has a cotangent value of √3? pi/6. Okay. Number 3. Inverse sine of √2/2. So again, inverse sine is 1 and 4. Because it's positive, I'm in 1. What's the angle in quadrant 1 that has a sine value of √2/2? pi/4. So now I want to find the tangent of pi/4. And the tangent of pi/4 is 1. You guys go ahead and do 4, 5, and 6 for me. So guys, for number 4, hopefully you guys came up with √2/2. So any questions on number 4 where we got √2/2 from? So now number 5, when I find the inverse sine of -√3/2, that should give me -pi/3, because the angle down there in quadrant 4 is going to be -pi/3. So now to find the secant of -pi/3, find the cosine of -pi/3. The cosine of -pi/3 is 1/2, and then you can just take the reciprocal of 1/2. So you should end up with 2 for number 5. Yep. And then for number 6, same idea. Again, the arc cosine of -1/2 is 2pi/3. So then to find the cosecant of 2pi/3, find the sine of 2pi/3. The sine of 2pi/3 is √3/2. Remember, sine is positive in quadrant 2, and the reciprocal of √3/2 is 2 √3/3. All right? So any questions? Again, guys, I can't emphasize this enough. This is where you really have to know and memorize the unit circle along with the inverse values, which is why we're having that mini quiz on Friday on those, just knowing those inverse values. All right? Any questions on these? So, like I said, we also have to be able to do composition. Let's go ahead and skip over to page 11. We also have to be able to do composition when you're not dealing with common values. So if the values are not common values, you're going to have to draw a reference triangle. So the way you set this up, again, you can skip step number 1. You're going to draw a reference triangle in the appropriate quadrant based on the restrictions from the inverse function. Remember, inverse sine lies in quadrants 1 and quadrant 4. Inverse cosine lies in quadrants 1 and quadrant 2. Inverse tangent, you're in quadrants 1 and quadrant 4. Inverse cotangent, you're in quadrants 1 and quadrant 2. As I've mentioned in every unit, we've had to set up triangles. If you get the location of the triangle wrong, the rest of the problem is going to fall apart on you. Always know your location and where you're going to be, where you are. And remember, using your SOHCAHTOA, we'll be able to set up 2 of the 3 sides of the triangle. To find the missing side, remember, you're going to use your Pythagorean theorem. And then we'll state the ratio of the outer function. So the outer function is what I'll use the triangle to set up the trig ratio. So you're still going to always work inside out. So inverse cosine of 1/3. So right away, 1/3 is not one of my common values from the unit circle, so I know that it's going to be a triangle problem. Well, inverse cosine. Where are you allowed to be for inverse cosine? What 2 quadrants? 1 and 2. So because it's positive, which quadrant is this triangle going to be located? 1. So now, there's my triangle. So now remember, I know that the cosine of some angle is equal to 1/3. That's what the inverse means right here. So by my SOHCAHTOA, what is cosine equal to? Cosine is equal to what sides of my triangle? Adjacent over the hypotenuse. So I can label my adjacent side as 1, the hypotenuse is 3. Do I need any negatives in front of the 1 or the 3? No. How do I find the third side of this triangle? What theorem am I going to use? Pythagorean theorem. So 3 squared is equal to 1 squared plus, and I'll call this side b. So 9 is equal to 1 plus b squared. 8 is equal to b squared. So b is equal to square root of 8. And square root of 8 can be reduced to what? 2 square root 2. So there's the third side. So any questions on how I've labeled the 3 sides of the triangle? So now this is where I look to my outer function. I look for the tangent. I know that the tangent of some angle by SOHCAHTOA, what's the tangent equal to? Tangent's equal to what? By SOHCAHTOA? Opposite over adjacent. So from my triangle then, the opposite side is 2 square root 2, the adjacent side is 1. So then my answer is just going to be 2 square root 2. So you use that inner function to set up your triangle and to find the sides of the triangle. Once your triangle is set up, you look at the outer function and set up your SOHCAHTOA ratio from the triangle that you labeled. So let's take a look at number 2. So we have cosine of the inverse sine, negative square root 2 over 3. So inverse sine, what 2 quadrants are we allowed to be located? 1 and 4. So because it's negative, what quadrant am I going to draw my triangle? 4. So any questions on why my triangle is in quadrant 4? So now remember, the sine is the opposite over the hypotenuse by my SOHCAHTOA. The ratio that they're giving me is negative square root 2 over 3. So my opposite side is the numerator, which is square root 2. The hypotenuse is 3. Where does the negative sign go? In front of the square root 2. Remember, some of you are still labeling hypotenuses as negatives. Hypotenuses are never negative. They're always positive because of that Pythagorean theorem. So any questions on how I've labeled my triangle so far? How do I find this third side? I'm going to use what? Pythagorean theorem. So 3 squared is equal to, now remember, you're squaring the negative sign along with the square root 2. So 3 squared is 9. What is negative square root 2 squared? 2. So I subtract 2, so 7 is equal to b squared. So b is equal to square root 7. Do I need a negative sign in front of square root 7? No. So that's all I can get from this inner function. So any questions on how I found the triangle? Now look on the outer function. Remember, from SOHCAHTOA, cosine is the adjacent over hypotenuse. So my adjacent side from the triangle is square root 7. The hypotenuse is 3. So the answer is going to be square root 7 over 3. So any questions on number 2? What's the denominator for number 3, even though it's not written? 1. So see if you can draw your triangle for me. Did you guys come up with a triangle that looked like this? Check your 3 sides. Remember, negative 2 has to be negative. So any questions on how I've labeled the triangle? If you guys get this wrong, the rest of the problem's wrong. So are we all okay on the triangle problem? So now let's look on the outer function. Cosecant of theta. Well, cosecant's reciprocal of what? Cosecant's reciprocal of the sine. So I know sine is opposite over hypotenuse. So what would the cosecant be? The cosecant would be the hypotenuse over the opposite. So then my hypotenuse is square root of 5. The opposite side is a negative 2. So any questions on number 3? Yes, Chloe?
On the test, you have to write out cosecant, like you know, like when we're trying to find it, we have to write how we got there.
What do you mean, how we got
Like
there?
where you put cosecant, is there's hypotenuse over.
No, if you just wrote cosecant of theta equals, that's fine. I just showed it so that you knew what sides I was pulling out. Yeah, Becky?
Are we going to test it on the 2 methods?
Unit circle and triangles, yes.
Okay.
Yeah, you have to know both the unit circle and the triangles. Okay? Now, some composition problems, guys, with the triangles will have an inner function with a variable. So what that means is that sometimes your triangle problems are not going to have numerical answers. They may have a variable as an answer. So again, you're still going to set up, again, scratch out number 1, you're still going to set these problems up just like we've been doing with the triangles. You're going to draw a reference triangle in the correct quadrant. Find the missing side using the Pythagorean theorem. You are going to have a variable in the answer, not a numerical answer. You're still going to have a set the ratio up for the outer function. You're not going to have to worry about rationalizing, because these will be not pretty radicals probably. So do not worry about rationalizing the denominators for these problems. I know that'll break your heart. So let's take a look at 1. What's the denominator for 3x? It's not written, but what's the denominator for 3x? 1. So again, inner function, inverse cosine of 3x over 1. It's positive, so I'm going to draw my triangle in quadrant 1. Remember, cosine is the adjacent over the hypotenuse. So they're giving me the ratio of 3x over 1. So my adjacent side is 3x, the hypotenuse is 1. I still have to find the third side. Just like I did in all the other triangle examples, what theorem am I going to use to solve for the third side? I'm going to use my Pythagorean theorem. So 1 squared equals, remember you're squaring 3x. What is the quantity of 3x squared? 9x squared. You're solving for b. So what's going to be the first step to get b by itself? I'm going to have to do what? Subtract the 9x squared. And then to get b by itself, I'm going to do what? Square root. So this side is equal to the square root of 1 minus 9x squared. So the only difference between what we did in all the other triangle problems is that that third side and the other side is going to have a variable as a side. They're not going to be numerical answers. So now I'm going to look on the outer function. So I know from SOHCAHTOA the sine is equal to the opposite over hypotenuse. So the opposite side I found to be square root of 1 minus 9x squared. The hypotenuse is 1. So again, your answer is just going to be square root of 1 minus 9x squared. So like I said, the only difference is the sides are not going to be numerical. They're going to have variables as their answer. You set them up exactly the same way. So let's take a look at 2. Arctan square root 3 over 5x. I'm drawing my triangle in quadrant 1. Remember, tangent is the opposite over adjacent by your SOHCAHTOA. So they're giving me the square root of 3 over 5x. So the numerator is the opposite side, which is square root of 3. The adjacent side I'll label as 5x. So any questions on how I've labeled those two sides? How do you find the third side? You're going to use what theorem? Pythagorean. So remember, c squared is equal to square root of 3 squared plus 5x squared. What's the square root of 3 squared? 3. What's 5x squared? 25x squared. So to solve for c, what am I going to do to both sides? I'm going to take the square root. I'm glad you asked that question. There is no addition or subtraction rule for radicals. In other words, because you have a plus sign underneath of the radical, you cannot just take the square root of this and add it to the square root of that. You have to leave it alone. There is no addition or subtraction property of radicals. You can't simplify it.
No, like, let's just say it was 25x squared and it was a plus 3, a 9.
Can't do it.
And then,
Can't do it.
no, but then what I was saying, you simplify.
You can't take off the square root sign and just make it.
You can't do this. This is not equal. This is what you're saying. You want to do this.
Yeah.
Nope. There is no addition or subtraction rule for radicals. You have a quotient property of radicals. You have a product property. Had this been a division under here or multiplication, you can simplify. Nowhere have you ever talked about an addition or a subtraction rule. Can't do it. There is no. They're not equivalent. They're not equivalent. Okay? So you can't do it. As tempting as it is, you have to leave it alone. Because there's a plus or a minus under the radical, you leave it alone. You can't do anything with it. Okay? You have a quotient rule. You have a product rule. No addition or subtraction rule to simplify radicals. Okay? So I know you, so just leave it alone. So to answer your question, Monica, no, you don't have to worry about simplifying it. How's that? So now look on the outside. So cosecant. Cosecant's reciprocal of what? Sine. So I know sine is opposite over hypotenuse. Cosecant is the hypotenuse over the opposite. So the hypotenuse is that ugly radical square root of 3 plus 25x squared all over the opposite side of square root 3. And remember, like I said, you don't have to worry about rationalizing the denominator, so you can leave it alone. Okay? So any questions on that one? So any questions, guys, like I said, on the composition?